In this example, we're given the acceleration and we want to find the velocity and position functions of time. We're given a coordinate system that's, say, positive up, and our acceleration in this case is a negative constant, and the constant we're calling g. G is a positive number. And we're given that the velocity at t is equal to 0 is some constant we call v0. The position at time is equal to 0 is another constant we call x0. We know that the velocity function of time is the antiderivative of the acceleration as a function of time. And so the antiderivative of a constant is that constant times time plus an integration constant. And since we know that velocity evaluated at 0 is equal to v0, if we plug that into the above equation, negative gt is just 0, and we get this additive constant c, which is just the initial velocity v0 in this case. Our velocity as a function of time is our initial velocity v0 minus our constant g times time. Next is the position as a function of time is the antiderivative of the velocity, and so the antiderivative of negative gt is negative 1/2 gt squared. The antiderivative of a constant v0 is v0t plus an additive constant. We evaluate the position at t is equal to 0, which is our initial position. We plug 0 into the above equation, and all that's left is the additive constant c, so we know that that is equal to the initial position. And thus we have finally our position as a function of time, which is our initial position x0 plus our initial velocity v0t minus 1/2 our acceleration, which is g t squared.